in this video, we'll see how we can get our development environment up and running with the Docker containers, and all our development will be containerized in Docker containers. So when working with Python, one of the biggest challenge is environment management. And I've seen a lot of people struggle with this. There are certain tools, so you can use virtual environment, VENV, or you can use Conda. Those are amazing tools that can be used for managing environments on a local machine. However, there is an alternative way to do that too. And that way makes most sense in our AI-based domain, essentially. So when we are playing around with agents and we are giving them intelligence, it makes sense to, containerize them so that in case they do something that they're not supposed to, their effect is containerized in a smaller environment. And while we are doing this, we will also see another way of environment management over here. So one of the ways of doing environment management is using dev containers. And I went through this process of installing dev containers in the previous video. In case you want to see how I did that, that's the video before this one in the series. So in this video, we'll take a look at how to use dev containers for environment management. So the process that we saw in the last video was there was a template. So there was this zip template that I have that I usually extract, and that gives me some kind of, a starting point to go with. And let me just rename this, and we're going to take CrewAI as an example, right? I was on this page right now on this agent framework. Let's take this as an example. And inside this particular folder now, we have test.py file. And there are some hidden files over here too. So let's take a look at this folder. So I opened it in terminal, and I'm going to do code dot to open our VS Code inside this. And we'll see that there is a dev container folder over here, right? So this .dev container folder has multiple attributes, and some of these attributes are files, and in these files we have like attributes that define what this particular dev container is. And we went through this in the previous video. All I want to show is that this is the starting point for us, how we are going to go and attack our AI based projects over here, right? So we are going to containerize these AI projects, and that's how we are going to do things. Before you start any particular dev container, always make sure that any other previous dev container is stopped. And so we are going to go over here, and let me see. Oh yeah, I have this particular old dev container that I was playing around with right before this particular video. So I'm gonna go right click on this and stop this dev container. The reason I do this is that if there are any network conflicts that have been initiated by this particular dev container, I don't want them to carry over with my current dev container. So just make sure you have stopped your any other dev container that you have, and then you are good. Another way, sometimes what I do is I do a prune. So you can do a Docker system prune over here, which will remove all your previous unused dev containers that are not running. And so like this Ollama and OpenWeb UI is currently running. So if you do a prune, it doesn't remove those, but it removes other attributes that are associated with your Docker containers. So because these dev containers are Docker containers essentially, so Docker system prune also takes care of these dev containers. It also removes any network routes or volumes or any other leftover files that you have related to those particular dev containers that are laying around. So let's get back to our main task. So we have our template dev container open. We renamed it to CrewAI, and we just want to, run some kind of CrewAI command over here, essentially, right? So all we are trying to do is we are trying to access our Ollama server, which is already up and running, right? So we have our Ollama server already running over here, and Ollama web UI already running. So which we also saw from this Docker view, that we have our Ollama server running and Ollama web UI or open web UI running. And if you need to see how I got this up and running, these are also in the previous videos. So what we are trying to achieve in this particular video is that we want to make sure we are able to access our Ollama server, so our LLMs, from the dev container, right? So that's something that we want to do. So if we go to this CrewAI, I believe they have some kind of they have this particular code that we can run over here, right? So but before, there is a prerequisite. So pip install CrewAI. So we need to first install CrewAI over here. How do we do that? How do we install the dependency of CrewAI into our dev container? So we just go to this requirements file. Whatever is in there, we don't need all this, so we're gonna remove this, and we just want to type CrewAI, and that's it. That's our dependency. We typed it over here, and that is done, right? We do not want the CrewAI tools. So CrewAI tools would be needed for this super dev tool over here, which we are going to delete. We don't want to do anything fancy in this particular example. So let's just copy this example now, and let's go to this test.py and paste it. So you will see it is complaining about that, hey, CrewAI is not available right now, right? It's complaining about that, and it won't once we rebuild the container. So when we rebuild the container, it will install these requirements into our dev container. So all these dependencies will be resolved. But let's clean up some of this code. We don't need this Serper dev tool, right? So I'm gonna delete that from here. I'm going to delete these open API keys and Serper API keys. We don't need all this. And we are going to use the local version of our Ollama server. So I'm going to uncomment it. So the shortcut for Linux is Control and the / over here. So our open AI base API base is localhost 11434, right? So this is our /v1 is the endpoint URL that mimics the OpenAI's REST API format. So we're going to use that. Model name, let's use a simple model. So I have already downloaded Phi3 model, and let me show you. So if I go back to OpenWeb UI, and in the settings over here in models, I have already typed Phi3 and downloaded it. I've already done that, so I don't need to do that again. The way you can see that model exists is by going to this delete a model section. I'm not going to delete it. I'm just going to check whether the model exists. And here it is, the Phi3 model. It's a small model. We just need to check whether it works or not. So that's why I use this model a lot. It's very potent model though, even though it is small. It is pretty good model. It is from Microsoft, and I absolutely love how strong this model is. So let's use this particular model as our example. I'm going to go back to my VS Code, and I'm going to choose this model as our OpenAI model name. And OpenAI key doesn't matter. You can provide anything over here. It is just completely ignored. We do not need this Serper tool, and any reference to the search tool we'll remove too. So let's delete this. We just want a basic, program working over here. No search tool we want. So this is in CrewAI, we have a concept of agent, tools, tasks and all that, right? So we want only one agent right now. So this is the researcher agent that we want, only one single agent. And let me delete all this noise over here so it looks simple. We don't want any tool assigned to it. We want verbose true. We do not want this agent to delegate its task to anyone else. We do not want any other agent at this point of time. I'm going to delete that agent. We just want one single task so that our agent can have just one task. And we go to the crew. I'm going to delete anything else, any references that we don't need over here. And it is the simplistic program that we can have, right? So we are gonna fix this particular import over here by resolving the dependency in the requirements.txt file. So when we build the container, this will go away, but this is the simplest CrewAI program that we can have, right? So we have our agent, we have a task, we have a crew, and then we are just gonna do a crew.kickoff, which will kick off this particular agent, and it will do whatever the agent is supposed to do over here, which we will start now. So the step number 1 over here is to build this container so that our requirement is resolved, right? So let's do a reopen in container over here, and that is what will initiate a build. So you see how this kind of reloaded and it is saying opening in container, and there is, it says to rebuild. I'll just rebuild this again. It's performing a build, and the biggest time that will take is to get our dependency in, which is the CrewAI's dependency. So you see how it is downloading the CrewAI's dependencies and it is installing it into the Docker container. And this is huge because this is where the environment management aspect of it comes in, right? So you have all these dependencies resolved and installed in your Docker container. So this is pretty cool. So I absolutely love the fact that I don't have to have, like a separate folder, like Anaconda creates that separate folder in your local machine. This is not happening anymore. This is happening inside your Docker container now, right? So all those Docker volumes that are being mapped, all those are getting kicked in, and all these dependencies are localized to that particular Docker container, which is huge in my opinion. So while this is getting done, I wanted to talk about one aspect of this particular dev container environment that we have. So when we will run the code, right? So we now have this particular code that will attempt to run from the Docker container, right? And so you see how this dependency is resolved now. So once we open this in our dev container, the CrewAI dependency got resolved. Why? Because it is being referenced from inside the dev container where the CrewAI was installed, right? So pip install CrewAI command was run just by the virtue of the fact that it existed in requirements.txt file for us. Now, even though the CrewAI dependency resolved, our localhost 11434 needs to be accessed from the Docker container, right? So will it happen? Most likely not. And I wanted to do this on purpose so that you can see when I will run this command will fail, right? So I'm going to run this now, and it will say it is attempting to, so the CrewAI part of it works, right? So we have our agent trying to attempt to connect to the local host and trying to get its intelligence from the Ollama server, but that intelligence cannot be caught because it cannot connect to that particular server over here. And this is what I want to show you in the logs that once it tries to make a connection, it cannot. And the reason why it cannot have a connection because the network isn't available to it, so localhost isn't available. How do we fix this, right? So in order for us to fix this, we'll have to take a look at how these dev containers are actually set up. So let's take a look at the dev container metadata over here, right? So let me make this a little bit bigger. So the section that we are looking at, so this is the dev containers metadata reference, right? So specification for dev containers. And if you scroll down to the place where we have image or Docker file specific properties, right? So we have all our image. So let me show you this. So you see how we have our Docker file related properties over here. But in the dev container, we are referencing to this particular Docker file, right? So the build.docker file, build.context, build.args, right? So you'll see over here, build.docker file, build.context, build.args, right? So this is the format that we are following over here. Now, at the same level, there is this particular attribute, run args. And you can run an array of Docker CLI arguments over here, which is huge. So now what we can do, we can put run.args at the same level as build, right? And we can pass an array of arguments. And by a little bit of Docker magic, so let's go to the Docker CLI arguments. And in that, there is a specific argument for, let me make this bigger too. Okay, so let's go down over here and there is a network, right? So we can connect a container to a network. And which network do we want to connect this particular container to? So if we go to this network tab, you can see that we can choose -- network equals something, and that will connect your network to that, right? And the network that we want to connect to is the host network. So if we go back over here and at the same level as build, right, over here, if we come down and if we do run args, and you see it already populated it because it knows the schema, run args, and all we have to do is network equals host, right? So by doing this, by doing network equals host, we don't want to install this Docker extension. I'm going to close this. What we have essentially achieved is this particular local host scenario, right? So we are now connecting the host network to our Docker. So local host will be resolved now. And this is something that many people struggle with, and many times they just give up using dev containers because, oh, I cannot connect to the host machines, servers. So, but this, as simple as this, one single line will resolve it. So we are doing, like, we are connecting two different aspects. We are connecting the dev containers run args, and we are also using Docker CLI over here, and we are merging those two concepts together to achieve this. So now that we have done this, we can save this file, very important. Right, and I'm going to close other files over here. So we're going to save this particular file, and we have to rebuild the container. So to rebuild the container, go down at the bottom, this dev container button over here, and then you can click on rebuild the container. And this is the time when if you have any other Docker container, you got to stop that. So any other Docker container that is referencing the same network, then it will cause an issue over there for you. So this is done. So it just needed some network configuration. So it did not do like a whole rebuild. I believe it just did a simple restart kind of thing. Let me try to run and see It was very fast, and that's why I don't know if it worked. But it should be fast because it was just doing network configuration. It wasn't rebuilding by adding any other, requirements, or we did not change the Docker file or anything else, right? So let's try to run our program again. So easiest way to run is to click this button. But before we do that, let's also keep our NVIDIA SMI open. So this particular terminal is very useful for us. Let me show you how I run this, so it'll be easier. So the way to run it is by using the watch command. So if you just run NVIDIA SMI, it gives you a snapshot at that particular time. We don't want that. We want to see it updated. So watch, and the interval that I want to update is 1 second. So N1, that's why. And NVIDIA SMI is the one that I want to keep seeing updates for. So I'm going to click enter over here, and it is updating every 1 second now. So if you see the time, it keeps on updating every 1 second, that NVIDIA SMI, and it does not keep the log of that. So it is the current snapshot of your graphics card in a way. And we have 2 Tesla P40s over here, and you can see that none of the Ollama processes are running right now because they're not being used. Okay, so now let's come back to our VS Code, and we will run this command, and hopefully we will not see any network related issues. So I'm going to click on run, and it is executing. So CrewAI gets initiated, and there you go. You see how Ollama server has loaded. So the connection has been made now, right? So the connection from our Docker container to the Ollama server has been made, and it has loaded our very small model into our Tesla P40 graphics card. And it is, you can see just by the amount of wattage being increasing over here and the load on the 2 GPUs that it is working. The agent is working. It is trying to extract the answer, and we'll see an output in a little bit over here on our screen. But the whole point over here was that we made it possible for us to connect the Docker dev container to the Ollama server, which is running on our host machine. And all our development from here on will be done like this, in this fashion. So try to use Docker always as much as possible when dealing with AI, because we do not want these AI agents to have access to our machine. So I'm just going to wait for a little bit more time. I think it takes sometimes up to 60 seconds or a minute, more than a minute to execute. And I can see that it is working. It is trying to get an answer to the task that it has been assigned to. So what is this particular agent? It's a senior research analyst is what it thinks. And its goal is to uncover cutting edge developments in AI and data science. And the backstory: you work as a leading tech think tank. Your expertise lies in identifying emerging trends, and you have a knack for dissecting complex data and presenting actionable insights. Okay, and its task currently is that it has to conduct a comprehensive analysis of the latest advancements in AI in 2024 and identify key trends, breakthrough technologies, and potential industry impacts. And the expected output is full analysis report in bullet points. Okay, no wonder it is working hard over there. And when we did a crew, when we created the crew, we assigned all the agents over here. So the only agent we have is this researcher agent. So that's the one that is assigned over here. And we have one task, that is this particular task, and we have our verbose set to true, and we have kicked off this particular crew over here. So I'll just wait for a little bit, and we'll see once we get the answer over here. All right, so we have the answer now. After doing its research, it came back with some analysis. Let's take a look. It says, okay, trends 1, trend 2, 3, 4, 5, 6, finished the chain, and all the details are over here, and then it printed its result, right? So the idea being that we have our large language model connected, and we are able to do research using these research agents, using the simple implementation of CrewAI, and connecting it to our local Ollama server running on the host machine, and connecting all this using the Docker container. All right, guys, thank you so much for watching this video, and I'll see you next time.